Welcome everybody to this circular cricket webinar. This webinar is going to be hosted by myself, Martin Charter, my colleague Lillian, and our colleagues Darshil from University of Cambridge. And I think we can sort of just introduce ourselves maybe when we do our individual presentations. This particular project, this particular webinar is the basis or the culmination of a series of different projects we've been doing over the last sort of 2 to 3 years, and particularly the Circular Cricket Project, which is a design acceleration project, and another project called ACCG, which is funded by AHRC. So you'll hear a bit more about this as we go forward. Next slide, please, Lillian. So the agenda is we'll give a bit of background on now 3 detailed surveys we've done of recreational players that built on an original pilot we did. We literally had the 3rd survey we've just completed, completed very recently. We'll then talk about various circular cricket gear prototype developments, findings from a repair and refurbishment workshop that we undertook in Yorkshire with some Afghan refugees, and then findings from research into local biomaterial development related to biomaterial and also looking at recycled materials in relation to cricket gear production. And then finally, some results and learnings from 3 pilot reuse schemes we undertook for cricket gear, and then a brief overview of a carbon calculator we've developed for the Lord's Taverners that we're taking forward into another tool to be used at a club level to measure carbon emissions or savings resulting from local reuse initiatives. So I'll give a very brief introduction before I pass over to Lillian and then Darshil. So ourselves, the Centre for Sustainable Design, are based at University for the Creative Arts, set up in 1995. Over the years, we've worked across multiple sectors and across multiple countries, mainly in Europe and Asia, less so in North America, but some experience in North America that might become, more interesting as a cricket develops in North America. We have a small team with multiple expertise, and then we draw in an experienced network of consultants that we've worked with in many years who bring in detailed knowledge and experience. I myself also chair the Circular Economy Committee for British Standards Institute, so working a lot across, the emerging area of standardization in circular economy that is growing quite significantly. We won't have time to talk about that today, but if anybody is interested in that and actually wants to get involved, please drop me an email. We also have, backing up our project work, we have 4 PhDs working across product circularity, virtual fashion, and repair cafes. And again, repair cafes is another story, as is virtual fashion that we won't have time to go into today. But also, we do have on the ground experience that's been useful, particularly for the reuse scheme, in that I founded and chair Repair Cafe, the UK's first charity in the space. So we're up nearly 100 Repair Cafe sessions we've organised, and they were up for a King's Award for voluntary service. So we're quite sort of multifaceted, in the team, and, with Darshil and our broader network. So this is a bit about the background that we bring into this. And also we're quite applied. So in our work, we've had quite a reasonable amount of publicity and also Darshil's work on the bamboo cricket bat that he might just bring in when he talks. We've had, coverage in, the Cricketer, Materials Recycling Weekly. We also very recently the Institute of Materials, IOM3, can't remember all the names. So professional journals in related to materials, cricket. We've also had some material in the Guardian, and then with Darshall's work, they were on Sky TV and across various podcasts, etc. So we've had some visibility, and we've been trying to expand that visibility now with more activities in terms of exhibiting, the actual activities. And we were recently at the Oval at Surrey's Sustainable 2020 game, which had 21,000 visitors, and there was an estimate of about 5,000 people passed through our stand. Not admittedly, every single one came and asked us about the project, but it's an area that we're keen to do more work on, just getting the results out and our physical prototypes in front of people to gain feedback. Next slide, please. So sitting behind the sort of cricket gear sector, which is an area that is not well documented, particularly if you look at issues to do with sustainability and circularity. And but cricket is the second largest sport, and it's one of the most gear intensive sports. What we've seen over the years is that cricket gear manufacturing has very much shifted towards northern Pakistan and northern India. Across the board, there is some remaining cricket bat manufacturing in the UK, and indeed there has been a small uptick in that. But essentially, the skills have gone in making particularly softs. There are some skills left in terms of making bats, but maybe the skills to make the bats are aging now. There are issues there about, if we want to produce cricket bats in the UK, should we be producing apprenticeship schemes to further that? Other broader issues in terms of, we've also found that there is a fairly fragmented cricket bat refurbishment sector. A lot of small individuals that people sort of tend to know through their personal networks, but all the repair refurbishment networks are poorly documented and are not difficult to identify. So essentially the skills have been lost broadly in the UK, and this has been documented in this red list of endangered crafts. So cricket ball making has pretty much disappeared, and there is only a small proportion of bat making left. And to our knowledge, no softs are produced in the UK. But if anybody on the call knows of anything, we're always very interested to hear anything on the matter. So next slide, please. So, as Moeen Ali, the England and Warwickshire Now player, highlighted, cricket is an expensive sport and is getting more expensive. If you want to kit out, if you've got a couple of kids or young adults, if you include the kit, the coaching, you may be, looking at budgets of a couple of thousand, and particularly if you have kids that start off playing cricket young and move through to adulthood, re-kitting kids over time is an expensive exercise. What we've also picked up is that in India, costs are also going up, but of course there's a lower per capita income in India. So therefore, issues around repair and refurbishment may actually become more important in places like India that has an obsessive culture around cricket. So that's another area that we hope to exploring in more detail with a project that we have submitted for funding. So cricket gear is expensive. Very little data on the cricket gear sector, generally speaking. And then when you look at the environmental aspects and life cycle aspects of cricket gear, that data does not exist. We have produced a model with a base with a series of assumptions, informed assumptions, to try and identify the amount of cricket gear that comes to the end of life each year. And there is a significant amount of cricket gear that comes to the end of its first life each year, and that you could argue, you know, is potentially waste, although we'll touch on this in a bit more detail. So cricket has generally started, the leading organisations who are looking at sustainability in cricket, which are a number of the counties, Surrey, Warwickshire, and a couple of others, and also the MCC, and to some extent the ECB, have now started to report on carbon emissions. But that mainly relates to the built environment. They're really not tackled the issues associated with the gear used to play the game. So we produce this model here. We've had very little data from within cricket to help us develop this further. And as we learn more about different aspects to do with cricket gear, we're going to, you know, optimize this model. But essentially, there's a lot of cricket gear potentially coming to the end of life each year, both within the adult area and also the junior or youth area. And Lily and I have seen it in clubs. And we'll come back to that a little bit later. And we'll also highlight a couple of key issues that are coming out of that. So essentially, in thinking about circularity of any product, really, this is the idea of maximizing the value of products, materials, and components for as long as possible. And there are a variety of different models out there to consider in relation to products, essentially. We use the 10 Rs, but there are other R models out there. So again, I won't dwell on this too much because we'll be getting into more of the detail related to this. So essentially, what we've come down to is really thinking about strategically two core themes. It's the design aspects related to the cricket gear and how we can make these potentially more circular, brackets more broadly sustainable, you know, and we are looking at some new models that to consider that bring in the social dimension in the making side of this. So you've got the design and development of the cricket gear itself, and then you've got what we term place, which links very much more to, you know, establishing systems for reuse, repair, and refurbishment, which one can argue is better done more on a local or regional basis. If you can retain the use of gear within locality, you know, and those services in a local area, you're also reducing your carbon emissions. So essentially, as I mentioned at the beginning, this webinar is disseminating the results of the two projects at the top there, and we've got these series of other projects that feed into that, plus other work we've done more broadly in, you know, across product circularity, circular economy, sustainability. Next slide, please. So I'll now pass across to Lillian, and I will see you a little bit later.
Thank you, Martin. Yes, so now I will present a very brief overview of the findings related to 4 surveys that were conducted between August 2023 and July 2024, with a total of over 1,600 players. And this will help us contextualize some of the further research activities conducted within these within the 2 projects, within the projects that we're presenting today. So a bit of a background on the 4 surveys. These were completed across a series of various projects. So the CCG, which was funded by the Circular Economy Hub, the ACCG, and 2 surveys were conducted within the Circular Cricket project as part of the DA funding. So the first survey was conducted with 42 players, the second with 548, and then the latest 2 surveys were completed with 507 players each. The aim of the surveys were to gain insight into players' attitudes towards the use of plant-based vegan leathers for cricket gear, circular innovations for cricket gear, and the use of repair and refurbishment services. Now, the first survey with 42 respondents highlighted that there is a significant number of players that have considered the environmental impact of their cricket gear, and there were high levels of interest in the use of both plant-based vegan leathers and repair and reuse and refurbishment services. However, due to the small sample of the survey, a larger survey was deemed necessary. And therefore, we conducted the 3 consecutive large sample surveys. So the second survey that was completed with 548 players aimed to increase the understanding of cricket players' attitudes towards the potential use of sustainable materials and interest in repair and refurbishment services. Now, now just bear in mind this initial survey, it was mainly male oriented. So we conducted a 3rd survey to include a 50-50 split between male and female respondents. And it also focused on gaining in-depth insight on the rationale behind the high numbers that were achieved during the first 2 surveys in relation to the acceptance of the plant-based vegan leathers for cricket gear and the repair and refurbishment services. And then lastly, a 4th survey, which was completed earlier this week with 507 respondents, aimed to gain further insight into players' high levels of interest on repair and refurbishment services and the use of plant-based vegan leathers for cricket gear. It's worth mentioning that the sample panels focused on respondents who actively play cricket, and therefore we excluded individuals who only follow the sport. Now I'll go through the demographics of the various surveys. So for survey 2, you can see here that respondents were primarily within the age bracket of 18 to 35. And as mentioned previously, 87% were male. Within survey 3, you can see how there was a 50-50, almost 50-50 split between female and male. And then for survey, for the 4th survey, there was a split of around 70% and 30% for male and female. Within survey 2, players were asked to rank the following topics around their perception of contribution to negative environmental impacts associated with the production of cricket gear. And as you can see within this slide, all topics were ranked equally. So this in turn suggests that there is limited awareness on the environmental impact of cricket gear production amongst players. Then in survey 2 and 3, we asked respondents to indicate whether they would be willing to use cricket gear that was made from plant-based leathers or renewable or recycled material. And as you can see here, that the numbers were significantly high, so between 85% and then 90%. Just to mention, within survey 4, these numbers were again confirmed the previous 2 surveys. So again, 90% indicated that they would be willing to use plant-based vegan attitudes towards the use of repair and refurbishment services. Within survey 2 and survey 3, we can see the high numbers that indicated that they would be willing to use these services if made available. And then we didn't ask this particular question within survey 4. So we wanted to get behind the rationale as to why this was survey 2 and 3. So with this in mind, we asked within survey 4 habits around repair in general, and then more specifically for cricket gear. So this slide shows that surprisingly, out of a sample of 507 respondents, almost 75% indicated to have engaged in self-repair activities. So initially we had anticipated that bat repair would be high, but not so much for pads, gloves, and clothing. Yeah, we will conduct further analysis on these results, but there are early indications of opportunities to establish circular business models that could focus on repair and refurbishment as a means to extend the life of cricket gear products. We have also started to conduct some cross-tabulations around the response in terms of gender. So for example, within the slide, we can see that there is a tendency for some of the means on how to dispose children's outgrown or unwanted gear. So sending to the community or recycling centre seems to be more prominent amongst male respondents, while donating to charity seems to be more prominent amongst the female population, well, players. Within this, within the left, we can see differences in considerations around the use of cricket gear made from plant-based vegan leather and the rationale behind this. So, for example, there seems to be a higher level amongst male players to use plant-based vegan leather as a means to reduce the carbon emissions and environmental impact related to the tanning and processes of animal hide leathers. Whereas the female respondents appear to indicate that they would consider using plant-based vegan leather to improve animal welfare, for example. Yeah, in terms of the overall findings from these surveys, we can conclude that the players' awareness of sustainability topics in relation to cricket gear appears to be low, and this is evidenced by the respondents assigning similar importance to the 5 topics associated with the production of gear. An initial cross-tabulation of data indicates that there appears to be gender differences in relation to perceived environmental issues associated with the production of gear and the reasons behind positive attitudes towards the use of plant-based vegan leathers and also reuse practices. From the 4 surveys completed, 90% of respondents indicated significant interest in cricket gear made from plant-based vegan leathers or renewable and or recycled materials. The surveys also highlighted across the 4 surveys a high interest in repair and refurbishment services. However, concerns remain in relation to the durability and quality of the repaired or refurbished gear. Now, while there are indications of positive attitudes towards the use, cost, and turnaround of repair and refurbishment services, the survey also highlights that there is a gap in understanding of the benefits associated with these types of services. And then lastly, the findings highlight positive attitudes towards the establishment of new repair and refurbishment services, and that there's a high percentage of repair skills amongst cricket players. So within survey 2, for example, 39% indicated that they had a basic level of sewing skills, while 26% indicated to have an intermediate level of sewing skills. And then for survey 4, 75% of respondents indicated that they had previously engaged in self-repair activities. And then I will, Martin.
Just a quick point. Yeah, I think just a couple of quick caveats on that. I think we weren't just asking the questions in a sort of, let's say, a sort of theoretical manner. We were saying if the vegan leathers performed as well, if not, as well as the existing alternatives. So it wasn't a sort of theoretical question. We were saying, assuming they do perform as well as the existing alternatives and they use vegan leathers, what is your view? And as Lillian has said, consistently, we've had very high interest. Now, we've also consistently had interest in the repair, the repair side. But as a sort of ex-player, I consider them still to be quite high. But that, even allowing for that, there is high interest. I mean, what our next strategy on the research side is, we may do some continued sort of survey stuff, but particularly we're going to be looking at more qualitative focus group work to really try and get behind some of these points. But again, I think there is a theme across the 4 surveys of positive interest. That's what we can say. Please add anything, Lillian, that I missed out there.
Yes, I agree. And then we are also analysing the data across the 4 surveys in depth, and we will make a report will be available later this year. So just for time, we have included some of the highlights of these surveys, but we haven't really gone into depth around the findings within today. So we will send a link to the results once they're available. So now I will move on to presenting some of the prototype development and user learnings around the development of circular cricket batting pads and gloves. So the first prototype I will present is a pair of batting pads that includes 4 circular innovations. So within some of the previous surveys, players indicated that the main wear and tear within pads included the wear and tear on the straps, as well as tears around the bottom part of the PU leather. So within these batting pads, we included the replacement of the Velcro straps to extend the life of the product. And then we also found that the internal components remained intact, even though some of the exterior part of the batting pads were slightly worn out. So in this case, we have reused the internal padding to produce these pads. And then we have also used Pinatex. So this is a pineapple-based vegan leather to replace the PU leather of existing pads. And we also, in a disassembly exercise, we found a knee guard within the pad. So we have used a 3D printed fishy filaments knee guards to replace the existing guard. This prototype has been tested by recreational players and high level players, as shown in these slides. And early feedback indicates that they are fit for purpose for lower league games. However, additional padding would be required for premium league games. Having said so, it's interesting to gain external biomechanics material to at least 65 miles per hour damage compared to leather.
Lillian, sorry, the audio is not very good, so maybe we should all turn our cameras off and see if that makes any difference.
Okay. Yeah, so yeah. So now I'll move on to the second set of prototypes that we developed. Is the audio better?
Yes.
Okay. So the second prototype aimed to facilitate the recovery of internal parts and components through the redesign of the external shell. And as you can see here, the shell includes a Velcro mechanism that allows access to the internal components to be reused with a new external shell. The internal components consist of 3D printed metamaterials that are designed for impact resistance. And these were produced by Canterbury Christ Church using a TPU filament. So here the idea is that the external part of the shell is the main area that is worn through play, and the idea is that players are able to purchase the external shell and then reuse the internal components. Lastly, a third prototype was developed to produce a pair of professional pads that only replace the use of the external PU leather with a plant-based vegan leather to test the resistance of the plant-based vegan leather under high level conditions. And additionally, we completed a retrofit exercise of the palm of gloves. So a pair of inner gloves. So what we did here was disassemble the palm and then replace this with a vegan chamois leather. However, as you can see in the images to the right, the performance of the vegan leathers are still require further development. So you can see how the material starts to fray, and this was only after 2 or 3 hours of practice. Additionally, a pair of inner gloves were developed using the same vegan chamois leather to replace traditional sheepskin. And early feedback from testing of these inner gloves indicate that they perform well. However, they could be improved with extra padding in the palm area, which we will seek to develop in further projects. In terms of production process learnings, each pad takes approximately 10 hours to produce, so this is 20 hours per pad. The cost of materials is significantly higher compared to traditional materials, and the professional pads were significantly harder to produce due to the extra padding, layers, and additional thickness. So as mentioned previously, one of the challenges of producing these prototypes was finding the relevant skills, and in the end, the prototypes were developed by an experienced prop designer. Martin, would you like to add anything before we move on to the findings from the repair and refurbishment workshop in relation to the development of the prototypes?
Sure. Thanks, Ian. I mean, I guess a couple of points is when we trialed the original pads at the Oval with two Surrey Championship Premiership players, essentially the feedback there was those pads were great and they liked, you know, the feel of them, the lightweight nature of them, but they felt, you know, at probably 60, 65 miles an hour, 70, you know, club level play, they'd be fine. But if you then go up to sort of Premiership and beyond, the padding within the pads wasn't sufficient for that. So that's why we upgraded to take up to the Pro pads. One of the indirect results that we still don't really have full understanding was with the machine balls used in the nets. Normally, those sort of hard, slightly rubberized balls would mark the pads, the guys said. So they'd have red marks over the normal pads. But with the vegan leather, for some reason, they didn't mark the pads. So that was a sort of indirect sort of point that we haven't really further investigated, but it was sort of, you know, interesting in itself. I would just say the other key point, going back to what Lillian was mentioning in the end, was that, and going back to what I'd mentioned, you know, the skills have gone in terms of softs, pads, etc., as we mentioned earlier. We sort of indirectly identified a theatre prop designer, and theatre prop designers have to be multi-skilled in what they do. And we've worked with that prop designer to develop our prototypes. So again, you know, we didn't sort of suddenly tuck in and find some manufacturing skills in the UK. We had to think laterally. And the various other sources I looked at to try and identify the skills came up blank for me in the UK. So this is you know, this is an issue, you know, the skills. Okay, thanks, Lee.
So lastly, before we proceed to the materials research development, I will go through some of the findings from the repair and refurbishment workshop conducted in York. So the aim of this workshop, and as part of the Circular Cricket project, was to develop a new production model for cricket gear manufacture by collaborating with or setting up a social enterprise to develop a UK-based production model to reduce the environment impact of the products, as well as the embedded carbon, while contributing to reducing social inequalities. With this in mind, the workshop aimed to provide upskilling in repair and refurbishment techniques for the sector as a pathway towards employment, and to provide local communities with social benefits through repair and refurbishment activities. The focus of the training was primarily on repairing and refurbishing cricket batting pads and gloves, and particularly focusing on areas around the wear and tear of the PU leather on the batting pads, as well as the upper part of the gloves. Also repairing internal padding exposure, replacement of leather palms, and the replacement of external or additional padding within the pads. So what we did within the workshop was to present participants with a repair process. So how to examine what type of repair is required, then identify the repair techniques and the material requirements, followed by what type of tools they would need, as well as the skills, and so for example stitching or patching, and then to conduct the repair and test the final results. So we identified these repair opportunities. So for cricket batting pads, as mentioned previously, repair padding exposure or repair the damaged PU leather. And then for cricket gloves, repair padding exposure and damaged PU leather, as well as replacing damaged palms with recovered or second life leather or recycled leathers. Then we presented a few examples of how to identify the repair techniques and the tool requirements. So, for example, within the cricket batting pads, repairing the padding exposure or the damaged PU leather, this could be implemented by restitching the tear or applying a patch to larger areas. And then these would be the tools and materials required, and the techniques would be unstitching, sewing, and cutting. So in terms of the overall findings, we asked the participants previously if they had any sewing skills, to which they replied that it was very basic, and these were sufficient to complete the repairs. We also identified that, assisted by the images of repair, participants appeared to find the requirements on how to repair quite straightforward. So this could be developed further for training material. Hygiene factors did not appear to be an issue for the repairers. So going back to the repair and refurbishment of the batting glove that I presented, I think that the odor of some of the gear could be problematic if we were to set up a business model on repair and refurbishment, but based on the cricket gear that we received for this particular workshop, this was not a consideration. And then participants responded positively to using the repair cricket gear despite the visible repairs. So some of the gear that was repaired within this workshop was then donated to the participants. In terms of the overall social benefits, participants were able to socialize with their peers, meet new people, engage with local communities, and they also indicated within a follow-up survey that there appeared to be mental health improvements, so fighting boredom, for example, and then help with to de-stress, positive environments, and the cricket gear donations are also being used to play, which also provides mental health benefits. And participants also mentioned confidence building and learning new skills.
Just a couple of building on a couple of points there. Again, just to sort of make it clear that the participants were 8 Afghan refugees who were staying in a refugee hotel in Leeds, and you know, so that was the background. English was mixed. Part of the process was we learnt more when we had a Pashto translator came in from Yorkshire Cricket Foundation in the afternoon, but it was very positive. They found it very positive. I think we found it very positive, and it's a good. It shows, you know, that with, you know, in that sense, randomly selected refugees. They could make a pretty good go at repairing cricket gear at a decent level. I think they recognised they would do it better a second time, but the standard of work was good. We found somebody who had been working in manufacturing textiles there, as one does with a lot of refugees. You know, there is a perception, but many are multi-skilled. I'd say the other just key point from a practical point of view is from Lillian's hard experience, and often you learn things through the hard experience. We would, if we were to take forward any repair and refurbishment services, particularly for the gloves, we would deselect certain gloves that failed the sniff test. So there are you know, we'll come back to it again a little bit, but you know, some gear is in that sense not fit for purpose in a second or a third life, you know, either through damage or through odor, etc., etc. So I'll shut up there, and I think it's sort of time for Darshil now.
Great. Thank you, Martin. Thank you, Lillian. Just as a quick introduction, I'm Darshil. I am an associate professor at the University of Cambridge. I co-lead the Center for Natural Material Innovation, where we look at a range of different bio-based materials, usually plant-based, as alternatives, sustainable alternatives for the creative industries, primarily focusing on the built environment sector, so for buildings, but also for vehicle applications and automotives in wind turbine blades, for example, and consumer products, including sports gear as well. We worked on bamboo cricket bats, or we have been working on bamboo cricket bats for about 4 or 5 years now, and hopefully this summer we are trying to spin out a company. My co-inventor, Ben Tinkler Davies, is trying to take this up the next step. We have been working on optimizing the designs of the bamboo cricket bats and working on user performance testing and technical performance testing to make sure that the performance is equivalent or similar to that of willow bats, for example. But with Martin and with Lillian, we've been working on alternative materials to conventional materials that are used in cricket gear. And just to set up the discussions, we should outline that firstly, these are our longer term visions or mid to long term visions. In the UK specifically, there is no cricket gear manufacturing sector, particularly focusing on softs. There is a little bit of bat manufacture. Perhaps a couple of the stages of ball manufacture are done in the UK, but otherwise there is not a real industry as such in manufacturing. And therefore, even if we want to consider making cricket gear in the UK, we need to set up resilient supply chains, think about skills as Lillian and Martin were discussing previously, let alone alternatives that can be produced in the UK themselves. So yeah, these are our long-term visions for sustainable material alternatives. The other aspect related to this is about understanding that currently supply chains are very global, and therefore completely UK manufacture might be very difficult even in the future stages, given the disparate and the discrete nature of manufacturing steps for complex cricket gear products. So the first part of the presentation focuses on the advancement of circular cricket gear products as part of the AHRC IAA project, where we focus on local sustainable material alternatives for cricket pads and gloves, so softs. And it's nice to combine these together because both are PPEs, both have British standards related to them, but neither specify materials that need to be used for these cricket gear, for example, and both primarily use synthetic plastics. So if we go to the next slide, we can identify the main aims of this specific project, primarily to identify lower impact materials as all potential alternatives, specifically if there are local bio-based materials that can be used for cricket gears and for these two cricket gears, as well as perhaps initial consideration in sort of a what-if approach. What if we could use food waste from production or post-consumer for the development of sustainable materials for cricket gear? In the next slide, just as a brief overview of some of the challenges, sustainability challenges for cricket gear. These are very highly engineered products that are complex. They are very multi-material, and these have become really apparent as part of the disassembly exercises that Lillian and the team has carried out. They have very intricate assemblies, and therefore not only do we need to consider the functional properties, but we need to consider in the selection of alternative materials how they might be put together and disassembled in the future as well. One of the things we identify quite early on is the large amount of synthetic plastics that is primarily fossil fuel derived that is used in these cricket gear, and these have market carbon footprint. There are a couple of components that are bio-based, that are natural materials, but it's predominantly synthetic plastics. And it is obvious also currently that these designs and the material choices are void of consideration for materials embodied emissions, design for manufacture and assembly, design for disassembly and end-of-life disposal. So another larger point to mention is that, in fact, it is reuse, refurbishment, and repair that should be considered at the forefront, and alternative materials are secondary considerations as part of making cricket gear more sustainable. And finally, just to define a couple of key words, which some of us might not be familiar with. Here we refer to bio-based materials or biomaterials as materials that are either wholly or partly derived from biomass. So they might be wood or wood-based materials. So paper, for example, or cardboard, where some resin might be incorporated. They might be cottons, plant fibers, but they might have coatings of some other forms as well, for instance. Leather is also an example of this, but it might have other incorporated materials to improve the performance. So, for example, a backing material of some form. There are also a subset category, which is a new form of materials that has evolved primarily in the past 10 years or so, which is the category of biosynthetic materials. And often these involve some form of bio or biochemical processes and some biotechnology or biofabrication that is carried out actually by living cells and microorganisms. So sometimes it might be microbial, it might be enzymatically driven, or it might be grown with mycelium or algae, for example. So often fermentation might be involved, or some form of enzyme or microbial processes. And next slide, please, Lillian. As part of these research, we incorporated a lot of lessons from previous projects, particularly the vegan leather cricket project, where we looked at over 120 alternative vegan leathers in the market, and we found that a significant proportion of them had plastic in them, which were non-bio-based feedstocks, and none of them met the performance criteria as required for sports or cricket gear generally. And in fact, none of them had really explored uses in performance applications, particularly in the sports market. We also identified a big lack of data in terms of performance and data in terms of verifying their sustainability credentials. And then in the Circular Cricket Gear project, which was funded by the CE Hub, we also identified that cricket gear comprised a large fraction of petrochemically derived polymers, primarily in the foams, cushions, molded components, and textiles. And there were opportunities for more plant-based materials to be used, but some of them might have their own end-of-life challenges as well. We're also again highlighting that the making and the supply chain of these with these materials is as critical as the materials themselves. So we need to study the materials alongside the manufacturing and the supply chain, the value chains, if we want to really develop a resilient manufacturing sector in the UK. Next slide, please. So as part of the advancements in circular cricket gear, particularly focusing on cricket pads and gloves, we firstly identified what materials are used for cricket gear. And again, we find, consolidating what we learned in previous projects, that about 80% of the mass of cricket batting pads, for example, is made from fossil fuel-based synthetic plastics, and they account for about 95% of the materials and transport-related emissions. 20% of the mass of a cricket batting pad, for example, is bio-based, but this only accounts for 5% of the embodied carbon. So in some ways, it does indicate that if we were to incorporate more bio-based materials, the embodied carbon would reduce. We also broke down the cricket gear components into specific components with related functions. So we had molded plastic and composites, such as that used in the kneecaps for cricket pads. that required rigid properties or impact resistant properties, but also lightweighting. And lightweighting was something that carried across in most of these components. We found high density foams and fiber filling and wadding was needed for cushioning and impact resistance and lightweighting, etc. And breathable linings and skins and coatings and adhesives were the other two categories that we identified, but they accounted for a smaller mass of cricket gear in terms of mass. Next slide, please, Lillian. And then we started to identify some of the sustainable alternatives that could be produced in the UK. So actually, we did find a number of different sustainable alternatives that were primarily plant-derived. They could be produced in the UK, or they were at least part produced in the UK, but we found that predominantly a lot of the raw materials were imported. And this is a theme that carries across. We found 4 key areas that were interesting, particularly a couple of industries that were currently underutilized and needed efficiency, so wood production and wool production. The UK, for example, England in particular produces a lot of wood, but it is used for burning for fuel, or it is used in pallet making or fence making. So for short lifespan products or not high performance products, but there is opportunities for their use, at least in the first life cycle, for more high performance products. There were some industries that needed revival. So the fibers and textile industry, historically, the UK was strong in these sectors, but there has been a gradual decline in these sectors, and there needs to be more support in these sectors so that more opportunities could be identified for high performance uses. And some industries are actually in infancies, but being supported, particularly, for example, biosynthetic materials. And we are seeing a large number of startups that are fueled by research and innovation with universities and through these apprenticeship programs that are being supported. There is also some scope for exploring the use of recycled and agro-food waste-based materials. But the principal challenges that we are identifying are that some of these materials are either new and untested for cricket gear, and therefore there is some issues around user perception, technical quality, and the general risk and innovation awareness of the cricket gear industry. There are quite clear upscaling supply chain challenges. And then there's also the fact that sustainability needs to be actually demonstrated through life cycle assessments and through better designs as well. Next slide, Lillian. Thank you. And in terms of sustainable cricket gear materials, we identify a number of different categories. So bio-based polymers and plastics, so bioplastics. And in fact, this is a focus that we explore. There are bio-based composites, so bio-based plastics that incorporate some natural fibers in them to improve the toughness or the strength or performance criteria. Then fibers and textiles separately, that could be plant-based or animal-based, so wool, and wood-based materials as well. There are some leathers or alternative leathers that could be used, and then microorganism or biosynthetic materials that I identified earlier, so algal or mycelium-based materials. Next slide, please. Thank you. In the UK, there is a growing list of producers that are exploring bio-based materials, because remember that the net zero targets that the UK government has set are being increasingly adopted by a various number of industries, particularly in the packaging industry, but also elsewhere. So there is a bit of a cascading effect that's taking on, and more people are trying to explore bio-based materials. But it does present a secondary effect. It means that many of these bioresources are finding alternate uses already. So we need to consider how we might need to look at resource efficiency with biomaterials more generally. So for example, starch and sugar are an important bio-based feedstock that could be even derived from plant feedstock or even food waste. However, we are finding that a large number of these bio-based materials are already being used for sweeteners, for example, or for secondary products. So we need to consider issues around these diversifying bioresources. diversifying bioresources. The other aspect we find is that currently none have specifically targeted the sports gear sector. So there is a long-term research and development program that needs to be developed to support this. And there are a couple of industries. So bioplastics is actually quite a small industry in the UK, in the EU, and globally. It's only about 0.5 to 1% of the market. And it's primarily targeting the packaging market. So the bio-based material sector is currently only being implemented in a specific industry. So incorporating them in the sports sector is a big challenge. Next slide, please, Lillian. With the bioplastics themselves, there are also a couple of other challenges. So some life cycle assessments have suggested that the effectiveness of biopolymers to reduce the carbon emissions in comparison to non-bio-based biopolymers that are fossil fuel derived, that is unclear. And this is primarily due to, for example, in some cases, the use of fertilizers, for example, in growing these crops, or perhaps secondary processing that might be required to produce these fibers. So in terms of the spinning processes, for instance. There are also secondary indicators, environmental impact indicators, that in some cases bio-based materials might have higher impact. So water use could be larger for bio-based plastics. Transportation is also something that needs to be considered, because in some cases, the feedstocks may have to be imported from elsewhere as well. Next slide, please, Lillian. There are actually a number of advocacy and network groups in the UK looking at sustainable materials, and we have identified some of them here. And this is a growing group again as well. Next slide, please, Lillian. In terms of biosynthetic materials from food waste, we find that this is an interesting sector that could be explored further, because about 6.7 to 9.5 tons of food is wasted annually along the supply chain, from production right through to household stages. And the largest amounts of food wasted items are from bread, potatoes, fruit, tomato, etc. And these have a rich range of material building blocks, particularly sugar, starch, protein, fibers, and oils. However, converting these waste resources into functional materials is not straightforward. And there are, again, a number of challenges related to this: supply chain, technological, perception, and entrepreneurial or legal challenges as well. Next slide, please, Lillian. And then we started to explore in much more detail what might the production flow look like, what might be the processing steps of some of these food waste related materials. And we are finding that some UK-based companies are already looking at these. So Florian, Aqualite, and Chipboard are looking at bioplastics like PLA and PHA from corn, sugarcane, and beetroot-based food waste. Arda Biomaterials is trying to look at beer waste, so spent barley grain and protein and fiber from it, from London breweries for plastic-free leather alternatives. And Modern Synthesis in the UK is also looking at food agro-waste based sugars for the production of textiles and leather alternatives as well. Next slides. I think you can skip the next two slides. Yeah, so this is again looking at apple skin, for example, or waste peels from grape and apple, or looking at fibers from pineapple or banana production as well, for the production of bio-based materials, including leathers. Next slide, please, Lillian. And then in the conclusions for the advancements in circular cricket gear, this is primarily just recapping the ideas that there are a number of different challenges related to performance applications in sports gear, but in effect, material innovation and sustainable substitution with lower impact and lower environmental impact materials in these cricket gear is an interesting thing that we should explore, but there are more direct, higher impact routes through redesign, reuse, refurbishment, and repair of cricket gear. Thank you. So if I go to the next discussions around opportunities for British biomaterials, in this we started to look at in more detail, if you go on to the next slide, Lillian, to trying to actually identify UK-produced biomaterials and build a database of these biomaterials and their suppliers, their producers. And we tried to distinguish, if possible, between fully homegrown produced materials and imported raw processed materials as well. And then we explored agro-waste based materials as well. Next slide, please, Lenin. In terms of identifying UK producers, this was a big challenge, because what is a producer, especially in the world where it is highly globalized, companies are multinational, there is a large supply and flow of materials, and often this is kept a secret as well, because you want to protect who your suppliers are. However, we were starting to identify some schemes like Made in Britain, Grown in Britain, that were specifically identifying companies that were that had certificates, for example, where 80% of their supply chain was UK based, for example, or there was a clear chain of custody that was apparent. For the purposes of this project, we identified UK producers as companies that were UK registered, so they were on Company House, for example, but they also did more than just act as an agent or a distribution sector. So they were either doing some form of R&D, they were doing some product development, or they were actually producing part or some of their materials in the UK, or their products in the UK. And in many senses, we found that there were only two cases where the flow of materials was very, very clear. Companies that had an explicit focus on social impact, so trying to alleviate poverty and trying to bring in development in specific countries. So with Ananas Anam and their work in the Philippines, for example, and companies that were working at very small lab scales or very small pilot lines. So for example, Biophilica and Arda Biomaterials. So this might change with upscaling, for example. Next slide, please, Lillian. And then bio-based materials and recycled materials. Again, this is just redefining. I think we have defined biomaterials and biosynthetic materials already. With recycled materials, we incorporated both open loop and closed loop materials. So open loop recycling is when we have, starting with plastic packaging waste, but then this might go on to use for something else. So for example, plastic packaging might be used later on and after recycling for shirts, for example, whereas closed loop recycling is when it's used for the same product after recycling as well. So closed loop recycling is much less possible, particularly in the UK with plastics generally. In the UK, about 40% of plastic packaging waste is recycled. However, only half of it is recycled in the UK itself. About the other half is sent to Turkey or Netherlands or Germany to be recycled. And 40% of plastic waste is burnt for energy recovery and 20% is landfill. So there is still a huge scope for improving plastic recycling in the UK. And the production of bioplastics is low, and the vast majority is not recycled, primarily because of the low scales of production. And even composting is controversial because it's only really biodegradable in industrial vessel facilities, for example. Next slide, please. So then we started to identify specific material alternatives or recycled material alternatives and the companies that were producing it. So for example, with coatings, we identified polyurethane coatings and their alternatives such as nitrocellulose lacquers, BWAX, BPUs, and the companies like TTC, Hagedorn, Cavestro, British Coatings Federation, etc. And the same thing was true for leather alternatives. So we found a number of different UK firms like Hyde Biotech, Amado Leather, Modern Synthesis, Ananas Anam, 3D Biotissues, Biophilica. But again, re-emphasizing that not all of the raw materials were always UK produced. Sometimes raw materials were coming from abroad as well. Next slide, please. And then this is just focusing on the rigid impact resistant lightweight components. So polystyrene, polypropylene, cane-based alternatives that we were finding in the UK and the companies. But again, we were finding that a large number of these, in fact, all of these companies were primarily focusing on packaging or non-sports applications. And even recycled plastics was quite a small sector, and none of that was targeting the sportswear sector. Next slide, please. We also found alternatives for cushion, foam filling applications and breathable linings, but many of these are repeats from some of the other slides that we've seen so far. Next slide, please, Lillian. So then we looked at some waste from, or looked at biomaterial from agricultural waste. And again, we found that a huge amount of agricultural waste is in the form of crop residues. And this is in the order of tens of millions of tons per annum in the UK itself. And such crop or food waste could be a useful resource for building materials or material building blocks. So sugars, starches, proteins, and these could be converted into bio-based materials or biosynthetic materials. And then we again explored some production flowcharts for a range of these materials. So in the next slide, I think we look at PHA, PLA production from agro-waste, and a couple of UK companies are already doing this. And increasingly, there is more funding from the UKRI or Innovate UK sort of projects exploring this. So Pulpex, Cellucomp, and Nova Biochem looking at bioplastics from non-food agricultural waste, Covestro, etc., looking at bio-based polyurethanes, Biophilic and Thamon looking at leaf litter waste for textiles and leathers, and really clever Biome, etc., looking at mycelium-based materials using agro-waste substrates as well. Next slide, please, Lillian. And then again, imagining what a process flowchart might look like for algal or mycelium-based materials. And increasingly, we find that the generic processes are quite similar, and there are lots of challenges related to, for example, inoculation and incubation, because these are biotechnology processes. There are very specific terminologies and equipment that is necessary, so a huge amount of capital investment, but also often lab-type settings that are needed, because these rely on enzymes and microorganisms to grow. So to help them grow, you need almost pristine conditions for high quality products to be developed. And that's a huge challenge for these sectors. So often it's an economies of scale sort of thing that you need to produce in large quantities for it to be economically viable. Next slide, please. So just concluding, I think avoiding repeating what we have referred to before, one of the interesting things that I thought of later on is that this is not just an opportunity for cricket gear manufacturers, but also actually for sports gear manufacturers to come together and explore, jointly undertake research and development for adoption of low carbon materials in the sports sector. Because a lot of these sports gear materials in cricket could also be used in many of the other cricket gear as well, in other sports gear as well. I think I'll wrap up there because we have a couple of other slides to go through. But if Martin and Lillian had some other things to discuss, yeah, please do mention these.
Hi, thanks, Darshil. And for time, we'll pick up the questions at the end. But just sort of moving on, I think, I mean, a couple of key points just in summary from my side is that in the terms of the prioritization at the moment is to start on a design, then potentially look at the materials in the UK, the locally produced materials being perhaps a medium and longer term issue or opportunity. And I so I think that's a key issue in the product side. So just moving swiftly on to allow us to have a few questions at the end. So essentially, through a related project linked to this, something called the Strategic Priorities Fund of UKRI, we effectively set up a process to try and organize 3 pilots, and a lot of the knowledge from this is fed through into this project. So essentially, we set up 3 pilot projects in terms of reusing cricket gear. So the idea is at a club level, you know, the hypothesis was there is a lot of stored cricket gear in attics and garages and the backs of clubs. And the idea was to try and put a couple of pilots together to try and sort of prove that is correct. And we set up 2 pilot schemes near Farnham with 2 club sides, and one with one of the largest clubs in the country, Spencer Cricket Club, up near Earlsfield and Wandsworth. Next slide, please. So in the UK, we have surprisingly, quite a limited number of organised reuse schemes. The largest reuse scheme is the Lord's Taverners, who have a recycling cricket gear unit in the east of England. And there are a few smaller initiatives that exist. We believe that there is also activity at a club level to some extent, but it's not been documented at all. At a county level, Yorkshire have set up something called the Cricket Programme that has spread to 3 cities in Yorkshire. That they had an enthusiastic sort of catalyst to develop it, but I think they themselves, and from our broader analysis, that's still just scratching the surface in terms of what they've been able to do. We found other schemes in Gloucestershire, and then a very sort of undocumented reference from Derbyshire. So again, all of this is very limited in an organised manner, and it's not spread evenly throughout the UK. Next slide, please. So as I mentioned, Yorkshire have set up the Cricket Programme. Next slide, please. And then Gloucestershire have set up a similar scheme, but they make this more on an event basis. So rather than having cages to donate gear over a poor period of time to drop off gear, what Gloucestershire do is they organise a process where gear is donated and then it's displayed for collection on one day. Next slide, please. The other interesting point coming out of this that the previous slide actually reminded me of is a lot of both Yorkshire and Gloucestershire refer to this as recycling. This is reuse. In that, going back to that 10 Rs, this is reuse. This is not materials recycling. So even as these things evolve, where the terminology is not necessarily clearly used. So Gloucestershire, again, nicely organised there. They run it as a sort of one-off event. Next slide. But also we found some evidence of Derbyshire setting up, but we didn't find very much detail on this. Next slide, please. So what we did was to sort of set up the 3 schemes in 2 near Farnham, 1 near Spencer. We ended up getting various supporters in this, and notably, Surrey Cricket Foundation came on board in the end, as well as to clubs, a league, etc., particularly in the Farnham projects. So 3 schemes set up. Next slide, please. What we've also done as part of the process was we produced a whole series of tools and guides for clubs to set up schemes themselves. And so basically there is a stack of resources out there for any club that wants to set up a scheme from scratch with quite a lot of with a lot of detail there down set up. So there's tools and resources set up. Next slide, please. However, in reality, in actually setting up these 3 schemes in practice, really the bottom line is one needs to keep it very simple. At a club level, they're engaging it in setting up a reuse scheme needs motivated individuals from a club and a catalyst like me to come in from the outside to set it up. The guys at clubs, generally speaking, you know, are doing their day jobs, you know, they play at the weekend, or they donate some of their time to the clubs. So they're very, very time poor. So Spencer are different in that because they're a huge club with 1,600 playing members, up to 80 games a week across all their teams, they employ a managing director. But he is also incredibly busy being pulled in all sorts of directions. So essentially this, you know, I guess one of the key things from this, clubs have no time to set things up. So you really have to keep any initiative very simple. And essentially there are two parts to this. There's the donation of the gear, you know, in the clubs, and then there's the collection of the gear for redistribution. The other challenge and constraint within this is for any of us that played the game, we know that you know, changing rooms are quite small, and effectively during the season the changing rooms are used, fully utilized, the bars are fully utilized. To set anything up in terms of donating the gear in the clubs, one needs to set up these schemes before the season or after the season. So there are various constraints as to when one can do this. What we did, however, within the local Farnham initiatives, we were able to bring on board a cost cutter store, effectively somebody I knew who I'd played with in the past, and he offered his store as a drop-off zone for the clubs, as long, you know, so people were starting to drop off gear in his storeroom, and then one of the chairs of the clubs came and collected it. So there was a sort of movement within a limited storage space. So these spaces where people can drop stuff off at any time was really important. Next slide, please. So effectively, cutting a long story short, we're able to collect within the three schemes within a limited time period over 450 items of gear. A significant proportion, probably 95 to 97% of the gear that came in was straight reusable, sometimes gear still in the bags. Little bit of cleaning up could be straight reused. So again, it proved there is gear just sitting there that has value. And if you set up the right schemes, engaging the right partners, one can then redistribute the gear to people who potentially need it to enable them to play the game. Next slide, please. So effectively within the scheme, we were able to, particularly in the Farnham, the two Farnham schemes, we collected around about about 180 items of gear, and then we were able to redistribute 50% of it back into the local market to 2 state schools, 15 cash-strapped families, and an Afghan refugee. What became clear latterly is that due to government cuts, actually really quite, in a sense, quite shockingly from a sampling I've had within a network in Surrey, no schools have budgets to buy cricket gear. So this, you know, or even other sporting gear. So that's in state school sector. So it wasn't surprising that the state schools, or 2 of the state schools, bit our hand off, and each collected maybe 30, 40 items of gear. So there's a real need in state schools. What we're also able to do, that next slide, is then through some other work we've been doing that I'll mention briefly in a few minutes, is we were able to then identify the, have you moved that further on, Lillian? Sorry, yeah. We were able to then identify the carbon savings associated with redistributing the gear locally. So assuming the gear was then used for a further 3 years, we will have saved, by redistributing approximately 50% locally, we would have saved approximately 1 ton of carbon. What primarily is happening within these schemes is because of the the relative organisation of the Lord's Taverners is a lot of the gear that goes for reuse is going overseas and not being redistributed in the UK, and certainly not redistributed at sort of local points. So a lot of it is going out to places like Rwanda, which is great from a social point of view, but you do have then the embedded carbon associated with transporting that gear quite a significant different distance. And Lord's Taverners do a brilliant job with limited resources, but I think there are, coming out very clearly, there are opportunities overseas, but also, within schools in the UK and within families that effectively just can't afford to buy gear for their kids. Next slide, please. I'll move on from specifically from this one. So again, you just in the Spencer Club, there was nearly 200 items that primarily came, was gear left in the clubhouses and the various facilities. So a lot of gear out there in the sense that is stored waste. Next slide, please. So again, I'm not going to repeat this. This can be picked up in the video, the recording. So a lot of gear out there. Next slide, please. Next slide, please. So very, very briefly now, and again, I'm not going to, and just I think I'll highlight this, Lillian, and then we can just sort of skip through to the last slides. So very briefly, we've been working with the Lord's Taverners based on a methodology we'd previously developed to calculate carbon emissions associated with repair. We developed a new calculator to calculate the carbon emissions associated with reuse, based on 1 year's data from the Lord's Taverners, and effectively we've produced a series of monitors to allow the Lord's Taverners to identify the carbon savings associated with their reuse programs. They will then be able to use that data to make better decisions and to report. And they will also then be able to report back the carbon savings to the larger organisations that supply cricket gear to them in terms of their programs. So maybe Lillian would just skip through briefly. So there's a series of dashboards here that are breakdown in a lot of detail. We have data now in terms of the carbon associated with different types of products. I think upwards of about 150 to 200 items. Next, just final slides. So learnings in the future. Again, I'm not going to go into great detail on this. There are opportunities to design cricket gear, and particularly softs, the areas we focus on, to reduce environmental impact. There's certainly a lot of waste in cricket gear, and one can set up the appropriate systems around reuse, refurbishment, and repair. We believe there are opportunities. And again, going back to the research amongst recreational players, there is certainly interest in repair and refurbishment services as well as bio-based materials. Final slide, I think. We are continuing to work on these areas in another smaller project that will start in September. We have submitted a large project to bring all the learnings together from these different projects, and we're starting a conversation with one of the major county cricket clubs and one major retailer about how to take forward particularly the reuse scheme.